All right, so now let's deal with an interesting looking graph. This is the graph y equals negative secant of x over 2 plus 2. What should that look like? Well, in this case, this graph could be found pretty easily using a cosine as a guide right here, right? Remember, secant is the reciprocal of cosine. And so we might ask ourselves, well, what would happen if we had y was equal to negative cosine of x over 2 plus 2? Well, for this cosine function, the amplitude is simply equal to positive 1, even though there's a negative in front. Remember, that means there's a reflection that's going to happen to the original shape. The period of the function is equal to 2 pi divided by 1/2, which is to say 4 pi. There is no phase shift. Even though we're adding something right here, it's not enclosed in a parentheses. It's not part of the argument of our secant function. So uh, no, there is no phase shift. Okay, but there is a vertical shift upward by 2. So what does that mean to us? Well, if we were looking at a cosine graph, then what we would be graphing would look kind of like this. We would have x values within 1 unit. Let's see, key points are at 1/4 of the period apart. So in this case, pi apart. And since there's no phase shift, we start at 0. And so our x coordinate values here would go 0, pi, 2 pi, 3 pi, and 4 pi for one full cycle of the graph of the cosine. Now, as far as the y value is concerned, let's look at just what would happen for our cosine graph. Well, with our cosine graph, normally we would expect that to go 1, 0, negative 1, 0, and 1. But what's happening? Well, number one, we're multiplying everything by negative 1, and then we're adding 2 to that value. So what we should do right here with these natural values is we should take negative 1, the negative of the value, and then add 2. So let's see, the negative of 1 the negative of 1, so that's negative 1 plus 2, that's going to give us positive 1. Well, all right. 0 times negative 1 is 0 plus 2, that's going to give us 2. 2 pi, we're going to get negative 1 right here. Let's see, the negative of negative 1 plus 2, that's going to give us 3. 0, well, we're back to 2 right here. And then for 1, we're back to 1. Well, this seems rather odd. What's going on right here? Well, let's put these numbers up on the graph and show you what's happening with the cosine function first. Each of these marks right here, we'll treat these as going up by a half a point each. So here's 1, here's 2, here's 3 along the y-axis. We can see that the minimum value for us is going to be at positive 1. So at each of our key points, pi, 2 pi, 3 pi, and 4 times pi within one full cycle, the key points go like this. We get 0, 1, put this in blue, 0, 1, pi 2, 2 pi 3, pi 3 pi, we're going to get 2 again, 4 pi, we're going to get 1, and then that pattern is going to repeat. And so if you were to just plot in a few dots to see what's happening right here, we see that the center axis of this cosine graph lies right here at y equals 2. Well, that actually kind of fits with what we know about vertical shifts. The center axis, so-called, of this graph is at y equals 2. It's the line y equals 2. And what's going to happen is if it were a cosine graph, the graph would start at -1 in one cycle, go towards 0, come up to 3, then come back down towards 0, towards 2, through 1, and then head back up, and we would be seeing this. The way we look at the vertical asymptotes for secant is that anywhere where the graph of cosine would give you 0 if there weren't a vertical shift is going to be the location of a vertical asymptote. In this case, in the initial function, we would have gotten zeros at pi and 3 pi. Well, for our function, this is going to be a vertical asymptote. So we're going to have a vertical asymptote at pi. And at 3 pi, if we wanted to find more values at which our vertical asymptotes are going to exist, because this is x over 2, right, normally for secant, we would say that our values of x were found, our values of x were found by saying that whatever it was not equal to 2n plus 1 multiples of pi over 2. Odd multiples of pi over 2 had to be excluded. The only difference is that instead of being x, it's x over 2. So we set our argument of x over 2 not equal to 2n plus 1 pi, and that is going to give us, when we multiply both sides by 2, x not equal to 2n plus 1 times pi. And what does that mean for us? Well, our vertical asymptotes are going to all occur at odd multiples of pi. So we'd have 5 pi right here, and that would be the location of a third vertical asymptote. Or if we went off to the left to negative pi, we would also have a vertical asymptote. Now the graph makes it a little bit more obvious what's going to happen right here. As we continue to draw this graph, we're going to have our branches come up, pass through values at 0, negative 0, 1, come down from infinity, pass through the point 2 pi 3, and then have a vertical asymptote come along, pass to the point 4 pi 1, and so on, all the way down the line. And this is the way our graph would look after we're done. So this is kind of what we wanted, and so we're all set. More to come.